All right, so let's go through a problem working on goodness of fit. So this problem says, for a recent year, the following are numbers of homicides that occurred each month in a city. Use a 0.05 significance level to test the claim that homicides in a city are equally likely for each of the 12 months. Is there sufficient evidence to support the police commissioner's claim that homicides occur more often in the summer when the weather is better? All right, so the null is what? Homicides occur with equal frequency in different months. So you always have that equality idea in the null. And the alternative, well, what's the opposite of everybody being equal? The opposite is at least one thing is different. So not at least two or any other, so at least 1 month has a different frequency. So there it is. Okay, so we're not going to write those down. Now, if we're looking at the formula sheet, this is a goodness of fit. So we're in this column here on the page. We do need to check that each of our expected frequencies are at least 5. So we're going to use StatCrunch to help us check that condition, but we should check that condition. Our distribution is chi-squared. Degrees of freedom is k-1, where k is the number of categories. And there's our formula down below. And so again, we're going to write out the formula, but we're going to let StatCrunch do this by hand. I believe alpha was 0.05. So we're going to skip the null and alternative on this one. Chi-squared, though, is the sum of O minus E squared over E, I believe. Is that correct? Whoops. Yeah, there it is. Oh, it's a big sum, though. Yep. That's right. We got to sum up all of those proportions there, if you will. All right, now it's a chi-square distribution, so it's going to look something like so. How many categories? Well, n is 12. There's 12 months, and so the degrees of freedom is k minus, so actually k, sorry, k is the number of categories. K-1 is the degrees of freedom, so 11. So if I was to go to StatCrunch and get my critical value, this would be chi-squared. Again, I just like to do this. I like to have visuals. First of all, degrees of freedom is 11. We're going to point to the right. And so 0.05, so 19.68, if you will. So over here, yeah, roughly, you know, .68 is where that rejection region is going to start. So now let's let StatCrunch do the most of the work for us on this. And one thing, having troubles with my Windows today. One thing is look for questions like this. If you see the data over here, if you click on this little icon, you can actually ask it to open it in StatCrunch. You might get a pop-up blocker that pops up. Just tell it to ignore that and retry it. And then it should open up in StatCrunch so you don't have to type all the data in. And again, the formula sheet tells you where to go. So stat, goodness of fit, chi-squared. So if I go back, stat, goodness of fit, chi-squared test. The observed data, that's in the numbers. Now, we said all the months were equally likely, so we don't have any expected column here. We think all the cells should be equal proportions, so we're going to select that. And select expected, okay, because we're going to use that to check our conditions. So if I hit compute, there it is. Now notice here all these expecteds are 42.58. That's what you need to look at for the conditions. The conditions all all need to be the expected values for the conditions all need to be above 5. Clearly they're all above 5, so we meet that condition. And then there it tells us chi-squared is 9.978 and p is 0.5323. So 9.978 and p is what was it? 0.5323. There it is. Right? And so we're going to be, I don't know where that's going to end up. Guess let's go to the distribution. So 9's about in the middle there. Not that it matters a ton, but I kind of like my pictures to be accurate. So this is where chi-squared ended up at. Clearly not in the rejection region, but again, if we compare p 0.5323 to alpha, we're definitely greater than alpha. So since p is greater than alpha, remember, if the p is low, the null has got to go. The p is not low, so we are going to fail to reject the null. All right. So that gets us everything we need, so we can just go back into the problem now, enter all our data. So 9.978. 9.978. And 0.5323 was our p-value, 4 decimal places. Good. And so we just said we failed to reject the null. And so we're going to be either B or D. There is insufficient evidence to warrant rejection of the claim that they're equal, which is the null correct. And last but not least, is there sufficient evidence to support the police commissioner's claim about homicides occur more often? No, we can't support that because we said they're all equally likely, so there's not sufficient evidence to support that claim. And so there it is. So the only other difference is if we had some sort of expected idea going on, we would just do that just slightly different in StatCrunch. You'd have to select that column rather than clicking the all equal icon. So anyhow, there you go. So hey, hope that helped, and we'll see you on the next video.